Okay guys, in this video we're going to learn about equivalent ratios. So in the last video you learned about ratios and you learned that they were a comparison, and those comparisons were either going to be a part to whole comparison or a part to part comparison. And I stressed in that video how you can write ratios three different ways, but ultimately the best way in my opinion was to write them as fractions. So you're going to see in this video why I said that fractions would be the preferred method, and we're going to talk more about WKU and how to use that method with these equivalent ratios. Okay, so I'm gonna go through some of these examples. So WKU, just to refresh your memory, so the first thing we're going to do is write our ratio in words. What is being compared? What to what? Okay. Then we're going to write what we know in our ratio, and then and that's our K, and then we're going to go with our unknown. What are we trying to figure out? Okay. So let's look at example 1 down here for our equivalent ratios. Whenever we make an equivalent ratio, before we start here with example 1, so if I have 2/3, okay, and I want to make an equivalent ratio, it's the same, you do this the same way as you would to find an equivalent fraction. It's just like renaming your fractions when you find common denominators. You're going to use identity property for this. So if I want to make an equivalent ratio, I'm going to take 2/3, I'm going to multiply that using identity property. So I'm going to change 2/3 by multiplying it by 1, but instead of 1, it's going to be a fraction that's equivalent to 1. So I'm going to use 4/4. So 2 times 4 is equal to 8. 3 times 4 is equal to 12. So therefore, 2/3 is equal to 8/12. Okay? And you can tell that something's equivalent if you reduce your ratios to simplest form. They will be equal. So if I take 8/12 and I divide that by 4/4, I'm going to get 2/3, right? So I get what I started with there. Okay, so that is how we make equivalent ratios. We multiply using identity property. Okay, so if I say list me three ratios that are equivalent to 1/4. Okay, what I would do is I would say 1/4, the easiest way is take that times 2/2, and I would say 1 times 2 is 2, 4 times 2 is 8. So 1/4 is also equal to 2/8, and then I would say times 3/3, and I could get 3/12. So 1/4, 2/8, 3/12. Okay, I could also take 1/4, multiply that by 4/4, and I'm going to get 4/16. So all of those ratios are equivalent. And if I took each of these and put it in simplest form, I'm going to end up with 1/4 at the end. Okay, so all I'm doing is using identity property here to rename the initial fraction, which I call my initial ratio, right? To rename it into my new equivalent ratio. So that's all we're doing. Okay. Okay, now that we talked about equivalent ratios and how to make those using identity property, what we're going to do now is look at these examples. You can clearly see the work down below. I just want to kind of go over a couple of these so you can see, I can explain how the work, how they use that work, okay? So example 1 says it costs $4.99 for 2 pounds of ground beef. How much will it cost for 8 pounds of ground beef? Well, this is where we use WKU. Okay, so my words are going to be dollars per pound. Okay, and what do I know? I know it's $4.99 for 2 pounds, right? They want to know how much will it cost for 8 pounds. So that's my unknown. Okay, so that's how I would set it up. See how it's nice and neat? Like I have my work right side by side, you know, as neat as I can write obviously. So what I need to do here is look and say, how can I get from 2 to 8? So you would say, oh, I need to multiply 2 by 4. If you multiply your denominator by 4, you must multiply your numerator by 4. And this is the same thing as multiplying by 4 over 4, like I just showed you to get the equivalent ratios. So when you do that, you take 499 times 4, you're going to get 19 and 96 hundredths. So 8 pounds will cost $19.96. So that is where that answer came from. Okay, so that was example 1. Okay. Example 2 said the average lion can run 250 miles in 5 hours. How long would it take the lion to run 125 miles? Well, again, I'm going to go W, K, U. Okay. And I'm talking about miles per hour here. Now, when you do your words, you need to think, does this make sense? So if I set that up and I said hours per mile, does that make sense? Is this something we say? So you would say, no, that's not right. I need to flip that around. Okay. So what do I know? I know that this lion can go 250 miles in 5 hours. What do I want to find out? I want to find out how long will it take him to go 125 miles. Okay? So then I need to look at this and I need to say, how can I get from 250 to 125? Well, I would have to divide here. And if I divide my numerator by 2, I have to divide my denominator by 2. Okay? And 5 divided by 2 is 2.5. So you would say 2.5 hours to go 125 miles. Okay? I hope that makes sense. And then lastly, we have, for every 28 students at school, there are 2 teachers. How many students would there be if there were 24 teachers? Okay? So, again, W, K, U. So I have students to teachers. I have 28 students per 2 teachers. They want to know if there are 24 teachers, how many students that is. How do I get from 2 to 24? I multiply by 12. If I multiply my denominator by 12, I have to multiply my numerator by 12. And 28 times 12 is 336. So there would be 336 students. Okay? So that is how we use the identity property right here to make equivalent ratios. If I would reduce 336 over 24, I could get 28 over 2. If I reduce that at the simplest form, I would get 14 over 1. Okay, so those would all reduce the simplest form, the same simplest form. All right, let's go to our next example. Okay, here is an example from the Go Math packet from school. Okay, so it says Celeste is making fruit baskets for her service club to take to a local hospital. The directions say to fill the boxes using 5 apples for every 6 oranges. So that is ratio language there. 5 apples for every 6 oranges. She's filling her baskets with 2 apples for every 3 oranges. So we need to complete these tables to find equivalent ratios. So here we have 5 to 6 is our equivalent, our initial ratio. So I'm going to start there first. So I'm going to take 5 over 6. I'm going to multiply that by 2 over 2. 5 times 2 is 10. 6 times 2 is 12. So this one is going to be 10 twelfths. Then I'm going to take 5, 6 and multiply that by 3 over 3. And I'm going to get 15 18ths. That's my next one. And then I have 5, 6, and I'm going to multiply that by 4 over 4. And I'm going to put 20 over 24 for that one. Now, you can see that you know about tables and your input output in finding the pattern. And so you can totally see that this is going up by 5. The rule would be plus 5. For the apples and the oranges is going to be plus 6. But just by multiplying by 2 over 2, 3 over 3, and 4 over 4, you can easily fill in that table. Okay? And if I reduce each of these ratios, I'm going to get 5, 6 when I reduce that to simplest form. Okay, so now we have 2/3. So if I want to take 2/3 and find equivalent ratios, again, I'm just going to start with 2 over 2. 2 times 2 is 4. 3 times 2 is 6. 4, 6. 2/3 times 3 over 3. I'm going to end up with 6/9. And then 2/3 times 4 over 4, 8/12. There we go. Okay. So again, if I reduce these ratios to simplest form, I am going to end up with 2/3. Okay. So that's how I can figure that out. Now, compare the ratios. Is Celeste using the correct ratio of apples to oranges? Well, let's take a look at that question again. So she's making fruit baskets for her service club. The directions say to fill the boxes using 5 apples for every 6 oranges. So the directions say that she's supposed to be doing this, right? And she is using this. So is she using the correct ratio? So the answer there is no. She is not. She's not using an equivalent ratio. Is her ratio higher or lower? Well, what we can do to look at that is look, this one right here, 5, 6, now come over here, 4, 6, her ratio is lower. So Celeste is not using enough what? Apples. That's how we can easily compare those. Okay? I hope that makes sense. Okay, last problem example here. This one's a little trickier. Okay, so you can see here that we don't have an initial ratio that we're starting with, do we? It wants us to complete this ratio table, but it doesn't give us an initial ratio. So we have to figure that out. So I'm going to start with this one here. Okay, so my best advice to you is to take this 24/18 and put it into simplest form. Okay, so in order to do that, I'm going to find the greatest common factor so I can reduce this. So I'm going to say 24 and 18. What will go into both? Well, I know 6 will. 6 will go into 24 4 times. 6 will go into 18 3 times. Okay, I'm one and done. My greatest common factor is equal to 6 times 1. My greatest common factor is equal to 6. So I'm going to divide my numerator and my denominator by 6 over 6 to get 4/3. Okay? So I can use that 4/3, my initial ratio there, to try to figure out how to get these other numbers, okay, with WKU. But I don't have any words here, so it's just a KU, if that makes sense. So I know that this ratio is equal to 4/3. I can fill in this 12, right? So what I know is I have 12, and I don't know this bottom number. But I can say, how do I get from 4 to 12? Well, I would have to multiply by 3. And if I multiply my numerator by 3, I have to multiply my denominator by 3. So that's going to be a 9. Okay? So now I have this one filled in. Okay? So once I have that one filled in, that makes it a little bit easier to fill in this first one with 4.5. Because if you kind of can use your number sense, you would know that 4.5 is half of 9, right? So, how would I get there? Well, I'm going to go to a different color here. Okay. I know that I have 12 over 9. I'm trying to figure out how to get to 4.5. Well, I would have to divide by 2. And if I divide my denominator by 2, I divide my numerator by 2. So this is a 6. Okay. So that should make sense, right? Well, now that I have that 6 filled in, that makes this 18 easy to get to, doesn't it? So now what I'm going to do, I'm going to go over here. I have K, which is 6 and 4.5. What am I trying to figure out? 18 and what? Well, how do I get from 6 to 18? I multiply by 3, right? If I multiply my numerator by 3, I have to multiply my denominator by 3. So I'm going to punch that in my calculator. And I'm going to say 4.5 times 3 is 13.5. So that's 13.5. So I could figure out all the values in this table just by reducing this ratio to simplest form to figure out what was missing in this example, and then using that to figure out the other examples. Okay, so I'm going to erase this stuff. I'm going to clear that. And then we're going to look at the other one. So that was one where you had to figure out one part of the problem, and then that kind of snowballed to figure out the rest of it. Ooh, I kind of want to screenshot that first. So the next one, we're going to work that one the same way. Okay. That one is, the next one is actually, it looks harder, but it's actually a little easier than that first one. So the next one, we have this one filled in for us. 40, I'm going to make that my K, 0.4 over 512. Well, my unknown here, I have 80.8. Now, I know I can look at that, and I can say 40.4 times 2 is 80.8. So if I multiply by 2 for my numerator, I have to multiply by 2 for my denominator. And 512 times 2 is 1,024. Okay, so that was pretty easy to figure out. And then if I have 40.4 for my K over 512, and I'm going to 256, well, what's 512 divided by 2? It's 256. So that means I have to divide my numerator by 2 also. So I would take 40.4 and divide that by 2 to get 20.2. So I'm going to fill that in. Okay. And now I have my 20.2, right, over 256. That's my K. And my U is 10.1. Well, same thing. I'm dividing by 2. So then I have to divide my denominator by 2. And if I take 256 and I divide that by 2, I get 128. Okay? So, as you can see, you can fill those in pretty easily once you have a starting place, using some number sense to try to figure that out. Okay? But using the K and the U is important so that you have that set up. I'm I'm going to put that one back on here so I can put a picture of it in the Google Slides. That way you can follow your work, and you start with one and then it gets you to the next step that you need to solve the other part of the problem. Okay, so like I said, I can't stress WKU enough. It's really, really a good strategy, and you guys should use that when you're solving these ratio problems. Okay, thanks for watching.